I'd like to welcome our presenters and the audience who's participating here. So our topic for this session is zero energy building case studies, and in particular, examples of passive house certified schools. I'm actually really honored to moderate this session and being part of this forum. My name is Beni. I'm a civil engineer, and I've been practitioner in civil and geotechnical engineering field for around 12 years. And I must say, most importantly, I'm a fresh passive house designer and very excited about it. Without further ado, I'd like to turn the floor over to Mr. Michele and Francesco. They'll be presenting their case study together. Before that, let me introduce them to you all. I'll start with Francesco. Francesco Nesi is a building physicist, passive house trainer, designer, and certifier, and CEO of the Italian IPA International Passive House Association affiliate, ZEPHIR Passive House Italy. His company focuses on spreading the low energy building concept throughout the Mediterranean and in many countries in the world besides Italy, of course. His main activity is offering consultancy to developers and private persons who aim at getting a cost-optimal building. Training for professionals and construction companies is also another important task of his institute. He wrote a book, Passive House, which sold more than 4,000 copies in Italy. And in the recent years, Francesco has been offering consultancy and support to developing countries like Cameroon and Bhutan, where a new building standard has been finally defined thanks to his work on the field. Let me introduce Michele. Michele De Beni is a professional building engineer and expert in highly energy efficient buildings. He's a lead green associate and accredited building designer and instructor for the Passive House Institute, and a competent practitioner in environmental acoustics of the region of Emilia-Romagna. His work includes field testing for buildings aimed at very high energy and environmental performance, such as blower door test and thermography according to Casa Clima, Passive House, and LEED Green building rating systems, and activities related to building envelope commissioning required by LEED rating system. He's a LEED Green associate, a certified passive house designer, a technical competent in acoustics in region Emilia-Romagna, and accredited operator in NDT non-destructive testing. The floor is yours, Michele and Francesco. I know you'll be helping each other presenting this first case study.
Yes, thank you very much. I take the floor. Michele, is your mic working? Just to check it.
We can hear you. I'm not seeing any presentation yet. Now it's on the screen.
Super. So yes, it works. Okay. So good afternoon. Thank you for inviting us to this wonderful conference. I'm always keen to support ZEPEV and the Turkish passive house and low energy movement since ever. So since as I got to know Tuba and Sid and so on, all the other guys who were working to spread in Turkey the low energy and passive house concept throughout our name. The name of our institute is Zero Energy and Passive House Institute for Research, which resembles very much the name of ZEPEV translated into English. So it was born few months after us, so we are following the same path. I'm always happy to support all of you. You're doing a great job there. So coming to the project, so I'm personally the certifier of this project, which is located in northern part of Italy, in close to Parma, in the Po Valley area. I was appointed as a certifier by the designer, who was Michele de Beni, in that case, the engineer, who designed everything, so including thermal bridges, mechanical, building services, everything there, and with the big support of the municipality. So the delegate from the municipality responsible for school and sport called us and decided to set up a public tender for retrofitting an existing very old and very badly maintained school, ground school. And the idea was to use some bio architectural patterns, including the use of wood as a structural resource, a structural material for the school itself, and the wide use of photovoltaics and renewables and so on, in order to show to use it as a showcase for the population and for the whole community of that city. Indeed, as you will see in the following slides, just at the end of this presentation, when there was the opening ceremony, in the end, even the governor of the whole region came there to support the local administration and to present the school as an example of sustainability to the whole community and to the pupils, parents and families and so on. And nowadays, still the director of the school is very happy about how it works. No major issues arose in the life of the school up to now. And as reported, pupils get less ill in comparison to other schools. So that's a major fact which we can record as you invest in sustainability and in high-performing building standards such as Passivhaus. But let me give the floor to Michele de Beni, and I will interrupt it from here and there to comment it, to do some remarks to the project or whenever I'm asked for. And we'll present together this beautiful project, which has been even published on one of the major national magazines as best practice for the renovation of a school. So please, Michele. You have to unmute your mic if you hear me.
Okay, sorry. Francesco, can I share my presentation?
Yes, please.
Okay. So, just a moment. It works? Okay, so as Francesco told us that
Michele, I'm sorry, I'm not able to see your presentation yet.
I see on my screen, just a moment. Okay. Now?
Let's wait for a couple of seconds. Yeah, it's loading. There you go.
So, as Francesco told us, this is the story of a redesign of a project. So the project, the original project was quite old. It's like the 2010. And it's quite interesting how can a normal design can be turned into a passive design working on some or many aspects, just many aspects, fundamental basics aspect to work. So the site is in the middle yes, it's on in the nearing of the hill of the Apennines zone. It's quite a climate is temperate. It's cold temperate, and what is really hard is that we in this site we have really a long and cold winter, hot summer, and hot and humid summer. So three different climatic condition, quite hard for to manage and to balance between the whole year long. And this is the area of the campus, and there was a green free area in the center. And the red line is the new school. That is a sort of extension of the primary school on the right. And as I told you, this is we redesign. We work as the consultant for the general contractor, and we redesign the whole project. And that's interesting that we use the PHPP as a sort of dashboard to focus and to better understand where we have to work more hardly. And another interesting thing is that the school, the building was designed trying to avoid the more the same principle of a residential passive house. So even in the winter season, in the cooling season, and the summer season, we follow the 5 pillars of the passive house, and especially during the summer, for design in the summer, we use really primarily to reduce the solar load for the radiation, and we work a lot on air tightness to achieve the energy performance. So we don't invent something different from the principle, and that's quite important for which is start this path for the passive house design, that the principles are really relevant even for non-residential building. And in this case, we use a really lightweight walls and with just 84 watt-hour each Kelvin for square meter. That is quite low compared to the traditional way to build a school here in Italy with bricks, stone, and cement. And one of the first things that we made is to move, for example, elevator outside the heating boundary. So that has been quite hard, but to have an elevator with air tightness certification is quite impossible, or it's really expensive. So we moved outside the envelope. And another thing is that this extension, this building, is connected to the rest of the campus with 2 points, or in 1 point, in 1 bridge, and another point that we work to have a structural separation is the stairs for escape during the fire emergencies. And another point is to have a new vestibule in the main atrium to control better the losses with uncontrolled ventilation losses. So that's quite important for preserve the energy of this huge atrium that you will see. So this is a section, and we put the technical room on the basement. And this is, you see, this is the blue square is a R&D unit, and the rest are the 15 classroom and other area of circulation. And another thing that this is on the right we have the south facade, and the old project had this overhang shading that is quite good for summer, but it doesn't work at all in winter, and with the heating load, the heating the heating load that the pupils and the people make during the utilization of the building, it was really important to have shading during winter too. And so we installed movable shutters on the south facade. And to decrease and to work as well in the primary needings, we use a lot of natural light, not only in the classroom and in the atrium, but even in the circulation area. So we install sun tunnels on the flat roof to light in all the corridors. This is the big atrium that works even like a sort of for a huge gain of solar energy during the winter. And another thing that we change the structure of the atrium that was in steel, and then we turn into wooden structure. And that was a lot better for thermal bridge and other things. Okay, this is the graph that shows you the TFA calculation. And for example, the atrium was really a weight for this calculation, because the area was really high, but the TFA weight was not so high because there are a lot of floor lost in the double volume. And another steps what the winds area reduction. So I compare the original project with a passive solution, and that I reduce a lot using sun shading, and as well as back panels to decrease a range around 40 and 45% all the south facade, south window, as well as the west facade. We reduce a lot the gaining of the solar. So you can see on the photo the shutters on the south. You see in the winter all the classroom was direct in the sun, and this is the overhang of the atrium and other elements for shading. This is the inside. You can see this is around April, and the sun shading works to make an ambient more delicate, with no direct lighting everywhere. So this is the element, the detail of the element. What is interesting is that with the U value, the U value of the all walls, it's around, the overall U value is around 1.12, and not extremely high prestige, high value, quite in the range of the good insulation, but not exceptional. Okay. So this is the external wall detail that you can see the air tightness layer in the blue line, blue dot line. The detail of the external wall with the flat roof. It's important that with a flat roof we use a vacuum barrier on the inside, and then we protected the roof with a metal element as a covering. Okay. This is the detail of the sun tunnel with that has an insulation element itself inside, and there is a glass that separates inside from outside. That is quite important for condensation problem. And this is the detail between walls and the foundation, that we insulate all the foundation with XPS extruded insulation element. So you can see here the detail between windows and walls. We use the external insulation to better decrease the thermal bridge between the frame of the windows and the wall. And on the right, you see the movable shutter that we put on the south facade. We use the only windows with a certificate, or the only certificate window that we used was the curtain wall for the bedroom that we has already a Passivhaus certification. Some analysis thermal bridge. I go quite quickly across through these slides because there is a lot of photo in the following. Thermal bridge analysis for the walls, for the roof, and this is a schematic idea of the HVAC system. So we put the RN units on the basement, and what is interesting that there was a problem between the south facade and the north facade, because a classroom during winter facing the south could gain a lot from the sun. Otherwise, the classroom on the north didn't have solar gain at all. So we choose to split the heating power between the ventilation system and a recirculation system that allows you to manage each area separately. So we have anyway a post-heating coil on the heating ventilation air unit, and this is another component with Passivhaus certificate, and this hardening unit has almost the power to heat the entire building, but we prefer anyway to have another heating system, a sort of turbo system, especially during the cooling season. Exactly, this is the hardening unit. And the classroom is a scheme of the HVAC of the classroom. You see there are supply air and on the right and exhaust air on the left, but there are another system that with recirculation can give you the power that you are missing. So different classroom from every classroom independently, okay? And that's quite important because you can share your power needs and your ventilation needs. That the ventilation needs, it's the same for each classroom, but the heating or the cooling needs depends a lot of the orientation of the building. So for hot water heating system, we have solar panel and a heat pump dedicated just for hot water production. And that's the construction phase, the installation of the foundation. even against the terrain. And this is the wooden structure. And you can see always the membrane with the tapes for air tightness. The roof, the precast wooden roof. The overhang element for shading always made with timber to decrease the heat flows for the connection. The external insulation with the mineral fiber 12 centimeter. The insulation of the basement. And you can see here the tapes to connect the vapor barrier on the inside of the roof. Yes, we had extreme attention with the air tightness, even with the structure for the carbon board, the gypsum board, and the connection. You can see we use tapes and sealing dedicated to the connection on the wall. This is the separation. You can see on the left the separation between the bridge that connects the old building with the new building that has an independent structure, so no connection at all. Even here you can see the outside stairs that is completely independent from the wooden building. This is the air tightness for windows. This is the vestibules of the main entrance. This is a photo about the triple glazing of the atrium, okay, with the curtain wall. This is the insulation of the foundation, the perimeter foundation, that is connected really in a good way with the external wall. Another insulation of the foundation. This is the taping of the windows roof for smoke. And this is another certificate Passivhaus component, this kind of windows. The photovoltaic system, and there are the thermal solar panel for hot water. Many thought about the taping and the air tightness, the membrane between pipes and structure. This is to close the iron unit on the right, you can see when you test the building with the blower door test, you have to close the iron unit, and this is the element that closes the pipes toward outside. Another element to pay attention is the threshold, because all the doors open toward outside. So we use different level of pavement or finishing to hide this threshold and to achieve the air tightness. This is a graph about the balancing of all the HVAC system that is required for certification. And this is the result of the test. We have to achieve to respect two parameters, the N50 and the Q50, one about the air change rate max and one about the loss for each square meter of the envelope surface that is required for big volume building for certification. Graph to use for this calculation, and many photo of the building at the end. The atrium and the connection between the new extension and the old building. This is the opening day with a lot of people really interesting. And the school are really, is not important how energy can save the school. That is really a lot compared to traditional building, is the message that this kind of building gives to the rest of the people. Inside the classroom, the main entrance, photo during the night, and that's the result. We achieve 12.7 heating needing each square meter, and the energy primary index is really low, 36. That's quite important, especially with renewable energy. And we can't give the premium class just for a bit, but we achieved the plus. This is the passive house plus certification building. So, Francesco, if you want to tell something about this common project and common experience, I can let you to talk.
Yes, thank you, Michele. I guess you explained it very well. Actually, if you want to come back to the slide you were showing before, yes, here, this is the school director, the school principal. Of course, this is in Italian, but we can easily translate it right now. So he's saying the school of Lecchio, of this town close to Parma, is not only a virtuous building. So within it, the pupils and the teachers are focused at fostering not only the sustainability made out of the materials used and of the school, but also to the behavior. So a sort of change of behavior, which is more focused on the consumption reduction through a very keen use of the energy. So closing doors, opening windows for the necessary air change rate should be done only for a few minutes, since a ventilation system is already present. Turning off the lights are few of the actions which just complete the design of a passive house building and to maintain the efficiency at an energetic level. So the idea is that when you really let the municipality and the public representative engage so much in the design, then the result will be amazing. And that's exactly what we have been doing in the past years by giving courses and by training also the public administration besides the component manufacturers in order to reduce prices of the passive house suitable components. And that's part of the activity which one major organization in a country should have, in my opinion, in order to foster and to support and to promote low energy building standards such as passive house. As you saw, dramatic, incredible attention to the details have been devoted to hit this amazing result, for instance, related to the air tightness. 0.6, less than 0.6 as a Q50 is a really great result, which you can only achieve by being at the building site, I don't say each day, but every second day, by teaching and training the tradespeople at the building site how to do this. Please call me whenever you have some issues or questions, and don't act, just stop and call me and I'll give you support, or I even come to the building site to teach you on site. So the idea was really learning by doing, also because the people there, the craftsmen, were not skilled before. Of course, training to the companies, construction companies, and to the tradespersons would help, but we could even reach great results, such as in this case, even when people are not so much skilled and trained. Of course, there's much more effort to be invested in the project when you have to speak the same language from designer to the tradespersons on the building site. But then, as you see, you can hit the result in any case. As Michele was showing, the old block was also refurbished up to the Retrofit standard, which is the Passivhaus standard for the renovations, and this has been also certified. And I think this is the only town in Italy which has not only one school but 2 schools certified, and a really visionary municipality and public administration, which, as you can see in these pictures, which is really supported also by the citizens, by the local people, as well as by the regional and government, as I told you in the beginning. So the lesson learned, of course, if a design starts badly, then you really hardly hit the target in the end. So we should really sit beside the administration when they just write down the tenders, the public tenders, and so on, and just helping them how to increase the quality of the tender and of the project, which will be subsequently implemented on site. And of course, all the designers should speak together and possibly the same language in what is called integrated design. So the Passivhaus standard is reliable, as is proven by the numerous testimonials given by the pupils, by the director, by the government, and so on, which are telling us, look, we have really great performances, not only regarding the comfort, but also the bills. Passivhaus standard. There was only a story. I can tell you a story. There's a problem because somebody hit the button, the alarm button, a pupil, and of course the ventilation system stopped and everything stopped, and all the school had to move out, or the guys or the teachers and so on had to move out, and they still didn't find who did this. But as you see, if anything happens, there should be also some alarm and something which stop the ventilation system and so on, in order to avoid issues which may arise if it was kept on. So Passivhaus standard for school needs an overall thermal quality, not only few high-performance certified components in a poor envelope. It's not that you just install a PV system on the roof and that's all. In order to achieve such a great performance, which is really close even to a premium Passivhaus standard, requires attention to the details, and of course a big care also in the communication between designers and craftsmen. To airtightness of certain components. For instance, the fact that in a school, the doors have to be open to the outside is one thing which you maybe don't think about when you design the school, but then on site you find this problem and you have to solve. So you please think in advance whenever you have to do with a passive house or a very low energy building, because if you fail the air tightness, especially in a wooden building, that might be very dangerous, even causing structural problems and so on due to mold and condensation in the building assembly. So to sum up, we could say that Passivhaus standard really needs a collaborative approach. Don't see the tradesperson as an enemy, but just one of your collaborator, one of your team. And by looking closely together to the project, we can reach such a big performances and being a showcase for the population and for Italy and so on, and now for Turkey, for people who are listening. So thank you so much for the attention. I don't know whether Michele, you want to add anything?
Thank you, Francesco. We're a few minutes behind. Michele, if you would like to add anything short, we can do it now or later during the question.
I'm okay. I'm okay. I agree with all that Francesco said. So
perfect. Okay. Thank you for the great presentation. I myself, I'm delighted to see that school. It's a great project. Right now, I'm about to give the floor over to the next presenter, which is who's Nidhi. Right before that, let me, as usual, introduce our presenter. Nidhi is a passive house enthusiast, committed to sustainable and environment conscious design. Everything to do with low energy buildings excites her. Recently, her major concern is the health and well-being of occupants in low energy buildings. She has many years of experience working in academics as well as industry projects, both in India and UK. She's also the vice chair of the board of trustees at the Association of Environment Conscious Building, AECB. Nidhi, floor is yours, and if you could share your screen. And I'd like to remind the audience that you can send your questions from now on. We'll be collecting them and redirecting them to our presenters. Thank you. We're seeing your screen now, Nidhi. Thank you.
Great. Just give me a second. Okay. Hello, everybody. Thank you. It's an honor to be presenting to everyone today. And so I work for a company called RAFT. It is Retrofit Action for Tomorrow. So I'm going to slightly disappoint everyone. I'm not going to talk about new build, but I'm going to talk about our approach to zero carbon schools. I am definitely going to talk about lots of zero carbon schools. So the company was set up by Harry Paticus over here in the middle center, and in late 2019. So we are just over a year old, and this year we've grown from 2 to 7 people. RAFT is a social enterprise. It's a non-profit community interest company. And we want to deliver zero carbon schools, but we look at embodied and operational energy and carbons. And we want to have a whole school approach to it, not just the building approach to it. So we are multidisciplinary practice. We invest a lot in monitoring and hence looking at and avoiding the performance gap. It is we have also developed sorry, where is my screen? Bespoke carbon audit template, which allows us to audit the operational carbon of every school. So just to give like a brief background, we have, as a company, a huge experience of deep retrofit projects, from Georgian Victorian houses to modern 20th century buildings to even buildings built 8 years ago. Range of typology, range of building fabrics, and in some cases, a range of approaches to just single building fabric as well. So in this particular one, this has been monitored since 2013, and it has 13 different types of insulation used in the building. It's from IWI to EWI. And this particular graph is of wood fiber insulation on the front external wall, and you can see that it's over 6 years to reach its equilibrium. So it's still not dried totally, and it's drying out. And so monitoring helps us to focus ourselves on understanding each building element and then developing bespoke approaches to it. In this particular building, this is Walter Siegel House. If anybody knows, Walter Siegel was a pioneer self-built architect in UK, and it is a timber frame house which can be easily built by anybody, and it was very popular in 60s and 70s in UK. And we have recently finished refurbishing it by using bespoke solutions again, triple glazing, air tightness. The front panels or cladding panels were removed, and aerogel insulation fitted behind it. And internally, it's got wood fiber insulation. It's also got regenerative MVHR, so which we thought was really cool. It looks really neat and decent, and it's decentralized, so not. So it's perfect for this particular house situation. And then it's all that experience that we now bring to our schools. And I mean, schools in UK has had various more points of growth. So in the late 19th century, and then in between war, and then in the 70s. And so we see lots of different building fabrics, lots of different types of schools with different history, so a different regime of maintenance and upgrading as well. So if we then go into much detailed study of the schools that we work with, we look at the whole history of when the repairs were done, when any maintenance activities were carried out, when extensions were built. And to form a picture or to understand the building first before we start working with it. In UK, there is not much new school building activity going on at the moment, but there are over 35,000 schools that all need retrofit. So, and we have a program of reaching zero carbon in each and every school by 2030. And so we are going to see more retrofit action than we are going to see new build in schools in UK in the next few years. So that brings us to this three particular schools, which I will share. It's we're doing some work this year, but before that, it's how we started. So this particular house is Harry's house, and it is the first step-by-step retrofit project that has reached NFIT standard. It's won lots of awards here in the UK and abroad, and this is where we honed the technique of achieving that step-by-step retrofit. This house took 5 years to retrofit, and we've been monitoring it continuously. It's been pre-monitored before retrofit measures and throughout the retrofit measures, and is now being monitored as well. We looked at embodied carbon and engagement, community engagement with local schools was very important, because we wanted this to become like a laboratory for learning, and we wanted the whole community to learn from it. So the materials that I used, everything was logged, and Harry's son Dimitri produced lots of posters and leaflets for the school as well, for the whole process, and that was shared. The tree in the garden was taken down, and that was air dried over 2 years, and then the fence and decking made out of it. So it all kind of, the embodied energy was really important. Yep, this is a poster that Dimitri made, and it shows the journey of cork from the trees in Portugal to the insulation in his house. And I really like the way he's like, in the end, he says, now we feel warm, and it was quite heartening. This is again at the school where we're teaching. The engagement with schools is a major part of what RAFT does. And we wanted to teach them about thermal properties and thermal elements. So they're working with different insulation materials in groups, and this is what we call the baked potato challenge or baked potato workshop, where they're all given a baked potato and they have to build a house for that baked potato to keep it warm. And after an hour, we go in and we take thermal images of that throughout the process, but we go in and measure and we see whose potato is the hottest. And unsurprisingly, and in a very enduring way, we always see that people forget to put any insulation on the floor, which kind of mimics what we do in real life as well. So that's quite interesting. And that has led to a whole school assembly approach. So we go to schools, we want the whole school to be involved. So it's not just going and delivering one single measure of retrofit or a range of measures of retrofit, but it is to getting the whole school involved in what's happening with the school. And in most cases, it's we start with the impact that the climate is having on us and why the works are first necessary. This is one slide which we produce every time we go into the school, and it is the flights coming in and out of Heathrow Airport on that particular morning, and it's like every flight and the amount of tons of carbon that has been produced, and the real life impact of this carbon emissions on various parts of the world, and its climate justice is very important to us as well, as I mentioned before. And we teamed up in one of our school retrofit projects. We teamed up with a school in Bangladesh where children then exchanged letters. So the school in London is writing to the children in Bangladesh, the school in Bangladesh is writing to children in London, and then the child in Bangladesh then attended an assembly that happened online at the school in London as well. So there's a whole exchange of how the climate is actually impacting the whole world and why we should be changing and retrofitting our buildings. But this has also hit home to us this year, because in London, this is a school in London, it's actually a colleague's son's school, which has flooded, and there was huge disruptions. It was shut down for 4 weeks. I just want to go there and turn the lights off, but I can't. But it has really hit home to us, and we've seen news headlines like 40% of schools in UK are now at flood risk, or are in areas of low-lying areas and are at huge risk of flooding. So this has actually hit home, and it has then led us to consider or expand our scope of zero carbon services, in which we now actually look at SUDs as well. So that's another thing that we've got involved into. This is a little video of Harry's son showing how, for one of our workshops where we asked students to go and do a home energy audit. So here he is explaining in this video how to do a home, how to fill out the home and energy audit in their home. And then this is them. We work with the children at school where the retrofit is happening, to then for them to then transfer that learning to their home. So it is that ripple effect and the whole community getting involved. Then we also do this whole school ecosystems workshop with the schools, where each group of children then work with any of these topics, and they research, they see how it affects them, why it's important, how it relates to the retrofit works that are happening at their school, and then we get them to create posters. We work with school children on a different kind of workshops as well. We look at waste that the school is producing. We get them to do a waste audit and see where they can cut down on their waste and to help reduce their carbon emissions as well. So we get them to do this. We look at food waste, and when this happens, the children usually just run away. But we want them to understand. We want the schools to understand how they're prepping their meal, how they're designing their menus, why there is food waste, portion sizes, and things like that. I mean, a typical school can produce up to 20 kg of food waste a day, which is 8 tons over a year. And if you're considering there are 35,000 schools in UK, you can imagine how much food waste per day and per year. So that is another thing that we want to kind of really have an impact on. And the retrofit of the school becomes the vehicle to do that. So with the retrofit, we do all these things with the schools. This is another school in London that we're working with, and we looked at their solar PV production, and this is a diagram of by one child of that solar PV production in that season, and they have done much more of other types of artwork as well related to the school retrofit. This is the carbon audit of the school that we carried out. We have now developed a bespoke template for carbon audit, where we're not just looking at gas and electricity, but we are also looking at scope 3 emissions. So we look at all the purchasing, all the supplies, all the goods that the school purchases, and the school travel, and how people come to school, and all those kind of things as well. And it's quite surprising, because it's like, when we brought the building down to zero carbon, is the school actually zero carbon, or is there anything else required? And there's so much more required for the school to actually become zero carbon, because building energy is just one aspect of it, and the purchasing is actually equal to the heat and hot water demand of that building as well. So there's equal amount of carbon associated with it. So we want to target that as well, and so we work with scope 1, 2, and 3 emissions, and we want to try and get the school down to a true zero carbon. And while we're doing it, air quality is also very important to us. So we don't want to leave school in a worse condition than we start with. So when we are in there, we want to monitor the air quality. We give schools out these air quality monitors so they can monitor their classrooms. And in some cases, we've now actually installed sensors as well, actually in 4 schools now. And it is because the indoor air quality with piecemeal measures is so bad. You have double glazed windows that cannot open properly, or have got blocked trickle vents, and it leads to CO2 accumulation in the classrooms to such levels that their understanding, their concentration is impaired. And it's just one example of one such window. It's like blown seals, blown double glazing, very minimal opening ability of that window. Because of safety and security, the trickle vent is blocked. And in some cases, teachers don't want to open the windows, because they wrongly think that opening the window means they're losing the heat out and using more energy. So the ventilation is really, really poor. And in our measurements of that ventilation or CO2 in the classroom, we've seen that the CO2 can actually reach over 2,500 ppm, and it impair the children's ability. So when children are falling asleep after lunch, it's not their fault. It's because the air quality, indoor air quality in the classroom is so bad. This is a school again, the right hand side of the school. So this bit is 1920s bit, this bit is 1980s bit, and you can see that there are really large windows and doors over here, and they were all meant to be opened, but with new double glazing and stuff and safety and security concerns, then they've got very minimal opening ability. And then in the 1980s was the build part, there is a huge atrium over here in the school, and this whole roof light is a single glazed roof light. And we do some historical research as well. And in our historical research, we come across school photographs, and we come across these type of lots and lots of these type of photographs where you can absolutely imagine that there is a fire going on in the classroom, and all the windows are open. There is ability to open these doors as well, and children just rushing out into the playground. We've seen pictures of insides of the classroom where children are sat with coats on and windows open, and it kind of brings home the whole last year that we've spent in a similar way, where the windows, because of the pandemic, the windows have had to be open and the doors have had to be left open, and the heating was on all the time, which isn't the great thing, but that is how the classrooms had to be kept ventilated, and hence the understanding of that ventilation and how much ventilation is required. And this is just an open an open air classroom, and outdoor activities being really important, and ventilation being really important. It comes from this early 20th century movement, open air classroom kind of movement. And this is a ventilation system in one of the schools where we're working in. It's really inadequate, and this is how properly installed MVHR would look like. And in that situation, this is what it should look like. Again, an open air classroom. So we worked with a music composer on one of with the monitoring data that we collected from each classroom, and it was a 3-day workshop where children understood what that monitoring data was, but also composed a musical piece out of that data. So that gets them really involved into what's happening in their school. Building fabric, again, it's a forensic analysis of the existing building fabric. So we go down into a type of detail, look at every element, look at what's happening, what has happened over years, how people or occupants are actually experiencing the existing building as well is really important, because most of the time things done to them from people who are not even involved in the day-to-day running of the schools, and hence fail to understand how people actually use the school. And that can lead to mismanagement or not, or spaces not being used the way they should be, or equipment not being used the way it should be. And in further investigations, we come across these type of things really often, where the insulation, the loft insulation, is just been ripped off, and it's piled up in one of the corners because there was some services installation or some repair work and was being done in the school, and they forgot to put the insulation back. Or in some cases, this is 1916 extension in one of the schools, and there is no insulation installed, and it's still past building regulations, which is just unbelievable. But this happens often as well. Or things like this. This is a thermal image of loft, and it has got a walkway around, and so there is no insulation being installed where the walkway is, or under the so nobody bothered to pull the boards up and install any insulation over there. So there will be huge thermal bridges and leakages. We use design pH and PHPP to work to analyze the buildings as well. So we're 3 of us are passive house designers, yeah. So this is the heat loss analysis. So a visualization showing the heat loss of the building over there. It's the yellow bits are single glazing, and this just allows us to evaluate the building. And we evaluate what's the best method to go forward, how whether the internal insulation would work, external insulation would work. In some cases, we see schools like this, really beautiful external fabric. So not a great contender for external wall insulation, but when you look inside, again, nice glazed tiles. This is a 100-year-old building. It's got really bad quality double glazed windows, but not much wall area. So when you look at the ratio of glazing to the wall area, it's insulating it either from externally or internally is not going to create much difference, and the most impact will come from actually installing good quality triple glazed windows. So it is having to make those type of decisions and looking at the whole building fabric holistically rather than in a piecemeal. Again, different additions to the school. So this particular addition over here is just an external walkway with a very poor quality UPVC double glazed windows, but no floor insulation or roof insulation, and the door and the classroom just opens out. So poor ventilation because the windows on the top are unreachable or unopenable, and the actual windows and doors are opening out into a poorly installed corridor. Again, this is another, in this school, we have got 3 really lovely Victorian buildings. It's a 1906 built school, and then various additions to the school over time. This is the latest addition. It's only 7 or 8 years old, but it's already falling apart. It's like literally standing in a cardboard building. So this is lovely building, huge windows again. So this is the same school over here. There is insulation installed at the loft level, but there is also insulation. I mean, sometimes it's well-meaning measures, but really badly installed and not clearly thought through. So you've got a reflective the reflective side of the insulations on the inside, and this is actually an unheated space, and with insulation over here, so there was no need to insulate over here, but we're also poorly installed, so there is thermal bypass. And we come across these kind of things as well very often in the school buildings. Again, this building, you see the windows are clouded, and it's only 7 years old. So it's so much of embodied energy as well. It's like, yeah, it makes me really sad when I look at these. But when you go look at the roof as well, it's like a patchwork on the roof over there, and you can see over here, it's like you actually step on it and then the water just splashes out. It's like a fountain of little water. It's the insulation. There is so much water under this membrane, and every time it's been patched over, but the water has not been let out. So the insulation is actually sitting inside a waterbed and obviously not performing. So new buildings to the regulations, but still not performing as they should. The solar PV is also switched off because the solar PV meter is in a class and it was heating up too much. So again, not clearly thought through of where the new equipment, the new measures should be going through. This is again concrete ring beam, so a huge thermal bridge. So we developed a bespoke approach to it. So it is receiving some aerogel insulation over there. At that particular junction, it doesn't remove the thermal bridge, but it definitely takes it down to a level where it's manageable. It's not a condensation risk anymore over there at that corner. And we get the premises managers involved as well in the works that we do. So over here, this particular manager is helping us drill holes and look into cavities. We look into the cavities and look at with the boroscope and see before doing it. It's basically understanding, diagnosing the cavities as well, and cleaning them out before any new measures are installed. So again, this is a bespoke detail for cavity wall insulation, where just to remove the rising damp and other issues, this is a foam glass granular fill below the DPC, and then a regular insulation on top. And over here, we actually thought, in this case, we thought that there was a huge structural problems on the site, and the brick and on the sill and the lintel were spalling. And on other
we're just going over a bit.
Okay.
Scheduled time. Just a reminder.
Yeah, I'll wrap it up. Can I have a minute to wrap it up?
Yeah, please, for sure.
Yeah,
sure,
okay, good. Okay, so I'll go ahead. And we thought that the concrete was spalling and the rebar was getting damaged, but it wasn't as bad as we thought on the further investigations. So in this case, the roof is actually a newly installed roof in 2019, and we went into the school and we took thermal images, and we were shocked to find, and when you went into the roof, actually you can actually see daylight and hear the thing. The junctions are not properly sealed, so we had a whole airtightness, develop a whole new airtightness strategy for something that was just built last year. And then this is an engagement in the building fabric. We get children involved in airtightness, in thermal imaging, and understanding their whole school before any measures are applied. And this is again a whole one school where the head teacher got really involved and was really excited, and she laid out all the archival material that they had, and the children were given white gloves to go and have a look at all the material. So I'm just quickly going to go through these. These are just certain elements which of history of interest, and we'll let the school keep them. We do a follow the heat workshop with the children, where they follow the radiators and the heat from the classroom into the boiler room, and they were allowed to come into the boiler room, and they actually recorded the sound of the boilers, and they came back and they made a presentation about it, and it was a sound of carbon emissions. So that was quite profound. And I'm going to really quickly go through this. We then look at all different options for air source heat pump as well. And in most cases, the obvious routes are not the best routes because schools have other priorities. And hence, in the end, we had to design this new support structure for the ASHP units. Again, in the same school, in a school. Actually, this is a very nice story. Just before I end, we had initially proposed an air source heat pump over here, and when we did a consultation with the children, the children were really upset because this was their favorite corner of the school, and one of the girls just stood up and said, "This is my throne. I sit over here and sing. So how can you put something over there? You can't take it away from us." And so we had to look at different things. So just in summary, it is a phased approach to building retrofit and to bringing them to zero carbon, and so we do a whole construction timeline of how the school becomes zero carbon, and then the whole school becoming zero carbon. So from the buildings to then their scope 3 emissions by 2030. And this is an artist representation, artist Owen Promery's representation of the work that RAFT does. So it's engagement, climate emergency, SUDS, and a whole school approach. And if you want to find out further, we've got some videos on our Vimeo link. So please feel free to have a look.
Thank you, Nidhi. Awesome presentation. There was a lot to see and digest in your presentation. Great examples. Hoping to discuss more during the questions and comments.
Definitely.
Before giving the floor to Naomi, I'll quickly introduce her. All right, Naomi is the executive director and founding member of passivhausMAINE and the founding board member of the North American Passivhaus Network. She embraces the challenge in developing passivhausMAINE into a sustainable organization through local, national, and international partnerships. She believes Maine's economic development can be fostered through a framework of building efficiency and innovative and traditional wood products. She lives in South Freeport, Maine. There you go, Naomi. The floor is yours.
Thank
we're
you.
excited to hear your presentation.
Thanks so much. I'm going to try to share this presentation.
And it was a bit dark when we started. I think in your room now it's quite daylight.
Daylight's come. Can you see my slides?
It's coming up.
Is it there?
I think still loading. I haven't seen this the slide yet. For some reason, I'm not seeing the slide. Oh, it just come up.
Okay.
Now we're seeing it.
Okay, great. Thank you so much for having me and for that introduction, and the other presentations, excuse me, are just fantastic. I'm coming from a different perspective for this particular project. I am the executive director of passivhausMAINE, but I'm not an engineer or an architect. I am, well, I came as a photographer, but this project in particular is about Friends School of Portland, which I was a founding board member of that school way back when. And I wanted to give the backstory of that project because I was wearing a couple of hats when I was a board member of Friends School and board member and chair of passivhausMAINE. So Friends School was developed in 2005, and we lived in a different location between 2005 and 2015. We were on a really cute little island that was accessible by a road. And we needed to build a new campus, which we did starting in about 2012 and move location in 2015. We have about 150 students now in 2021 in our new location. So starting just with the sort of basis of Friends School, which is always was a small private day school in Portland, Maine, and a school whose focus was really tuned to nature, as I say, and preservation of the environment in both a political and non-political way. The school was always really mindful of how we live on the earth. And when we realized that we needed to change location, the design process was very deliberate and very thoughtful. We needed to choose between an in-town location that was connected to bike paths right in downtown Portland, would have been renewing a brownfield site, a site that was quite polluted, but we wanted to bring it new life. Or the other option was being out in the country in a nice wooded site and really be sort of integrated in nature. The board, through a very careful process, decided that we needed to be true to the real nature of our school, which was basically a nature-based school. In that decision-making, we decided that most important was to make sure that everybody in the school was engaged in our decision-making, and that in the process of going out into the country, a location that everybody would have to drive to, we would commit to the lowest possible energy, net zero construction that we could. So we hired our architects, we hired our builder, we hired our passive house consultant, and the board, the chair of the board of directors and the building committee had this array of choices of how to build. And not to really necessarily dig deep into these numbers here, but it was apparent that going for passive house would be cost effective over time. And the board decided to aim for passive house, but not commit to passive house up front, because this was actually a fairly long time ago now, almost 10 years ago. Passive house was still new, not super well understood. I was very careful in wearing my hat as the board chair at Friends School and also my work at passivhausMAINE. I didn't want to have a conflict of interest there. And so I really let the building committee lead the way. So we said, okay, we're going to aim for passive house, but not commit to passive house. Rather, we took this approach of design without eliminating passive house as a possibility. And that was a really interesting design exercise, which started, for instance, at the very, very beginning when we were deciding where are we actually going to put the building. And we had a few locations on this raw wooded site. You can see we had about 24 acres in Cumberland, Maine. And if we were to have located this school somewhere on the southern edge of the property, we would lose the opportunity for solar gain. And so, right, one of the very first questions we had to answer about the location, we answered with a pro passive house answer, which was to put the building on the northern edge of the site so that we'd have room for solar gain and that passive house wouldn't be eliminated. I love this image right here because it represents looking across the administrative suite and into what we call the meeting room. It's the big room. And this was the original, this is what it looked like before we started. I also want to give a nod to all of those giant trees that were on site, which we harvested and used in the development of the building. The second inflection point, a moment when we realized, oh, make sure that we're really designing to passive house standard. It was understood that we were designing to a really high performance standard, but not understood that we were going to reach passive house. And at a certain point, we said, oh, what's really happening with these windows? Because there was a drive to have gigantic windows looking out into the courtyard and into the rest of this beautiful natural setting. And I actually take credit at that moment for having said, well, what does our ratio look like? Are we going to have too much solar gain that would require too much cooling in our shoulder seasons? And so we did have to readjust the windows to reach our passive house loan. That was a moment where we might have messed it up at that point, but we moved on. This is a picture of the Friends School in the winter. We're in Maine. It's very cold in the winter, and great opportunities for sledding for students. The third inflection point in designing our high performance building was the HVAC system. And we realized suddenly that, I use this picture because you can see the vent up there in the the very top edge of this photograph. We realized that the Zender unit that we thought we might use would not actually fit in the building. And we had to compromise. We ended up using a Renew Air system. I don't know if that's a system available outside of the States, but it's not a Passivhaus certified unit. So we would take a hit on the calculations for using a non-Passivhaus certified machine. And I actually really thought at that point that we would have a beautifully performing building and a beautiful building, but that would not reach Passivhaus standard. So it's a bit of a disappointment. But in the end, we realized that if we just added a couple more inches of insulation beneath the slab, we would reduce energy load by just enough that we could actually reach our Passivhaus certification goals. So that was a huge conversation for our board to say, okay, is it worth adding more foam insulation to reach a sort of abstract goal of building certification and to get our plaque? And the board decided that it was that important. It was important enough to add a little more foam, which actually raised our carbon load relative to our energy load, just more foam. But that it was important to make a bold statement to our Friends School of Portland community, but also to the greater Portland community, to the Maine community, to our regional community and a global community, saying Passivhaus, low energy, attention, this very careful attention to our building design is the way of the future and is how buildings should be done. And so Friends School did that, committed to this. Obviously, all of these decisions made before any kind of shovel was dug into the ground, before any building was actually done. They committed to the design, and as a result, we had this beautiful building. This image you can see is the meeting room. Friends School of Portland is a Quaker school, Friends School. This is the meeting room. All of this wood was harvested from the site. Those big planks that you see on the ceiling are almost 3 feet wide and 13 feet long. 90+% of all of the wooden trim in the entire building was harvested on site, kiln dried and used in construction. And as a result, we have so many schools in Maine. So we have now 8 school campuses and buildings that have committed to Passivhaus in Maine. And I wanted to just show briefly all of these other schools that were inspired. So Friends School of Portland opened in 2015. Maine Coast Waldorf School, which is only about less than 10 miles away, opened in 2016, designed by a different firm, but built by the same firm. In Belfast, Maine, also in 2016, there was a Montessori school that was built. That's about 2 hours north of us in Maine. Keep in mind that Maine is a total population of 1.2 million people. It's a very small and rural state. This is all 3 schools now in 2 years. 2 years later, in downtown Portland, Waynfleet School built a whole addition, built to the FIA standards. And then the next year, Bowdoin College, which is a small private liberal arts college, university level, actually has now 4 big passive house projects. These two are 2 dormitories, and then there's another small science building. It's like 4 buildings for each of these 2 projects here, these dormitories. That's in 2019. In 2021, the ecology school opened up. These are dormitories built to living building standard with Passive House baked into that. And they have another big community center on that same campus built to living building standard and Passive House. This school is also committing to a retrofit, a Passive House retrofit of their existing farmhouse. In 2022, this project will be finished. This is College of the Atlantic in Bar Harbor, which is about 3 miles north of Portland, or 3 hours north of Portland. A massive community and common space designed by Opal. And finally, in 2022, we have 500,000 square feet in downtown Portland at the public University of Southern Maine, Public University, right there in downtown Portland. So again, this is 1.2 million people in Maine, all of these schools built to Passive House and Friends School of Portland. I realized that I did not give great inside shots of Friends School of Portland, or really a lot of detail about the design, but here we are. This is Friends School from the outside with a rendering of the expansion that was required. We were worried when we moved from that cute island up to this wooded site that we would lose enrollment. But in fact, people were so excited about the Passive House piece of the school that our enrollment stayed steady and even gained in that first year of transition. And now, 5 years later, it was really even 3 years later, we realized, oh, we need to do that expansion right away. We have enough demand for expanded enrollment. And so we added another addition, Passive House Standard. It's all offset by those solar panels that you can see there. It's a total net zero campus with 150 students, which really was a catalyst for this burst, wonderful burst of Passive House schools in Maine, spanning the small private day schools of those examples that I gave before. This is a private day school. This is a private day school. This is a private day school. And then going into the university levels and public university. This is really a remarkable cluster of Passive House development in Maine. We are waiting. This is my goal for all of my founding of Friends School, founding member of NAPHN, founding member of Passive House Maine. I would really love to be on the building committee of a public elementary school that would be built to Passive House standard, that could realize all of the benefits, not just in indoor air quality, but also fiscal benefits, which is the primary motivation from all of these small schools. In Maine, anyway, the heating load, the heating budget line item every year is this traditionally a very scary, unknown, large amount of number 2 heating oil. It's cold in Maine, and that cost can make or break. It's a difference between making or breaking a balanced budget or not. And with a net zero building and a Passive House reduction of heating and cooling costs, it creates this security and stability for a financial plan, which is so important for every school. I think I'll leave it at that. I know that we're sort of tight on time, and my background being more from an organizing perspective rather than a technical architect or engineer perspective, I leave it there, and very, very open to questions and comments and thoughts about how we can move Passive House in a larger scale. Thanks so much.
Thank you very much, Naomi. Yes, we're really tight on schedule right now, on time. It's past 30. We don't have much time to answer all the questions. I'll ask everybody a general question. Maybe you can give me an answer in a few sentences. I'd like to ask you about your vision in promoting zero energy buildings or net zero buildings, especially the schools. Why the schools are important. Through your presentations, I captured some important sentences. The kids are actually being educated in these schools. We're not only providing a building to the planet, the building with low energy consumption, but the kids are educated in those schools with good air quality, with reduced energy consumption, with increased level of understanding how the ecosystem works. They're almost using this environment as a laboratory, as a workshop. So what will be your vision? Why schools are important? I'll start with the first presenters, Francesco and Michele. Just a few words, please. If we have more time to us, I'm going to jump into the other questions. Thank you.
So thank you. I'll start then. Actually, I've been teaching to the pupils in that school. I've been there after we built the school and after the pupils used it from several times. And we tried to educate them really in the classrooms, in the 5th class, some of the highest classes, of course. But pupils were so motivated, and then we brought them down to the technical room. They were really excited to see how the mechanical lungs of the building work. And I guess, so in my opinion, investing in the schools is so much important, really, because pupils are bringing this sustainable message to the world in their whole life. And that's why we started from the school also in Italy. And yeah, that's the key, you know, let them engage and learning by doing.
I'm sorry, my mic was off. I'm receiving an alert that we will have to end the session in about 5 minutes. Michele, would you like to add anything to that comment?
Just that people learn more by experience than watching a presentation on a screen. So that's why I always touch the excitement on people that visit a school every day, hundreds of people. And I'm really aware that we cannot work so much on single residential. We have to work on the public building and in existing buildings. So that's why we don't need to do passive house for magazines. We need to do passive house to make people understand that if you make a good choice at the beginning, you will do a good choice for your customer and for environment for 50 years. So that's why I like to
Thank you, Michele. Thank you, Michele. And Nidhi, I really like that hot potato challenge. The kids were trying to protect the heat inside the potato house. Very great examples.
Yeah, it's great. I mean, the schools are the future, isn't it? And schools are also the hub of the community. So in one head teacher's words, it's like the school with 400 kids can have an impact for almost 5,000 people. So that she herself imagines that that's how many people she touches by just by just that particular school getting involved in a project like this. So it's a ripple effect of what we do with the schools that is caused beyond the school building itself. And the school building then becomes a hub of learning, not just the primary education that they're there for, but also about climate emergency, because we are in a climate emergency. We have to bring our carbon emissions down, and it can really have huge impact. And if every school got involved, then the whole community can be lifted up, basically, in terms of carbon. Yeah.
Thank you. And not only the students, but their families are educated.
Exactly.
Indirectly.
Yeah.
Naomi, last words, please, and thank you very much, everybody.
Yeah, I can only say, using Maine as an example, that there's this room for momentum development from the schools, and using cost as a defining factor is actually quite effective. And those private schools with their unified vision on the board is an easier sell than the public schools. But that's my goal, to really have our public schools in Maine embrace a passive house approach, and then that exponential impact on students, teachers, parents, and municipalities in general is just huge. I'm looking forward to that. And thank you so much for the opportunity to present.
Thank you. Appreciate your presentations, your answers. There were some technical questions also about the installation techniques, the thicknesses, how things are being done internally in the schools in the UK due to the old buildings, historical buildings, and some questions about how the ventilation being really important in this time of COVID-19 pandemic. And I understand that the administrations are still also working on that. They're not sure how to attack that problem. I think globally, everywhere, we're trying to keep the schools open and keep the education going on. Hopefully, Passive House certified schools will be providing a good environment for the kids in the future years. Anyway, just to wrap up, thank you very much. Appreciate your presence here. Thanks to the audience being with us. It is the end of our session. See you in the next session. Thank you.